All right, so the next section is 3.2, which has to do with some fundamental identities. Now, the beginning of this we've already been over, so hopefully it's review, and then we're going to add an identity, and then at the end we're going to add, we've been talking about how sine and cosine curves are the same and related. We're going to talk about how they're related and do some problems there. So the first one, just to review, if you remember, what is cosecant? Right, cosecant, if you remember, the S's and the C's don't go together, or however we memorize that. That's 1 over sine. I think we've been over that before. What is secant? Secant is 1 over cosine. All right, and then cotangent, if you remember, is 1 over tangent. So if you remember, that's important when you put it in the calculator, because there is no secant, cosecant, cotangent button. Now, the reverse of this, which we didn't really talk about before, then what is sine, right? So if you look at sine, sine would be 1 over cosecant theta. Okay, now these lead into some proofs or some verifications that we're going to expose you to a little bit. Not very practical to solve. But then, of course, this would be 1 over secant theta. This is just sort of reversing the process. And this is 1 over cotangent theta. Okay, by the same token down here, if we were going to undo things, if you remember, tangent is equal to sine over cosine. Remember that from before. And, of course, then cotangent very easily is cosine over sine. So with a little twist, I think we've been through those. All right. Now, identities in math means that these are sort of laws, if you want, things that work. And again, in Trig, a lot of times we do proofs to undo things. And if you take advanced math in college, they'll ask you to have that. Now, we're going to expose this to you, and then we'll see how far we go with the actual problem solving with it. But the first one I would like you to know, the Pythagorean identity that works, is sine squared theta plus cosine squared theta equals 1. And I'm hoping that makes, oh, there's a square here, sorry. And you know that that means squared. So that's the, when I say sine squared, right? Sine squared theta is really sine of theta squared. Okay, that's the shortcut, just so you know. Hopefully that makes sense, because if you think about it for a second, if I have the unit circle here, right, and I draw this line here, does it make sense that this dot right here, that right there, would be cosine, and this vertical side would be sine? And do we remember our Pythagorean theorem that cosine squared plus sine squared gives you the hypotenuse? And in a unit circle, guess what that is? It's 1. So hopefully you have some basis for that. Now the other two we're just going to kind of throw at you. There are two other famous ones that we can use, or I'd like you to just sort of recognize, I guess. One is this, that 1 plus cotangent squared theta equals cosecant squared theta. And again, this would be applied in some proofs and stuff. The other one that's a little more common is tangent squared theta plus 1 equals secant squared theta. So I just need you to be familiar with these last two, or be able to recognize them as identities. The top one I'd like you to memorize, though. Okay, is that's cosine squared plus sine squared equals 1. Okay. Now, if we come down here then, let's see if we can simplify some things using some basic rules. All right, so the first one is, let's try to simplify this. So if I have cosine of beta times tangent of beta. So if I was trying to simplify this, the idea would be to re-represent stuff, right, in different forms to see if it helps me. So I don't know if we can do this, but what is tangent? Tangent would be sine over cosine. Do you see kind of as a little bit of a puzzle? How could this be reduced then by rewriting using some of the identities? Just so you know, that would be just that, because the cosines would simplify. So there would be value in that if you were doing an advanced math problem that had these, okay? How about the next one here? What would secant be? Usually if we rewrite them in sines and cosines, we just see if anything goes away. Secant is 1 over cosine. What is cotangent? It's cosine over sine. And then times sine. Ooh, wow, everything kind of goes away. Now remember, when you cross things out, they don't disappear, they become 1. Are you with me on that? So usually we don't write the 1, but I just want to remind you of that. Look at all this goes away. What do I end up with? I actually end up with a bunch of 1s, and that could be reduced to be 1. Okay, if you're following. All right, so that's just kind of what we would like you to be able to look at and do. All right, yeah, some basic examples of that. All right. Now, the next thing I want to go over then, we're going to hop all the way to the bottom here. All right, has to do with cofunctions. All right, so down here, all the way down here, where is it? Here it is. This is important, okay? So we talked about this before. Remember how we said if we've been graphing sine and cosine functions, they are the same curve, they're just shifted, okay? So these cofunctions here, if you want, they're shifted by pi over 2. Now, I'm hoping we taught you enough that you know what pi over 2 is. Pi over 2 is 90 degrees, all right? And everything can be related that way. So here's how this works, okay? If I take sine, all right, and I take pi over 2 minus the original angle, it relates to being exactly the same thing as cosine. All right, look over here, this is kind of interesting. If I go to cosine and I take 90 minus the original theta, guess what I go back to? I go back to sine. So sine and cosine are related. They are shifted by 90 degrees. These other trig functions are also shifted by 90 degrees. If I would have secant and take 90 minus the original theta, I would end up with cosecant. All right, if I had cosecant and I take 90 minus the original angle, I would get secant. Down here, tangent. If I take tangent of pi over 2 minus theta, I get cotangent. And if I take cotangent of an angle that's 90 minus the original angle, I would then get tangent of theta. Now, the main one, of course, that we're going to use are these. This is one I'd like you to memorize. The other ones I just need you to be familiar with. But let's see if we can do that then and see. So for letter A, if I was going to express this as the cofunction, this is kind of cool actually. We can check it on your calculator if you want. What is sine of 43 equal to? Sine of 43 is equal to the cosine of 90 minus 43. So if we check that on our calculator, if you would put in sine of 43 and put in cosine of 47, you would get the same answer. So kind of interesting maybe. All right, a little more obscure, but still good to know. What happens if I had the cotangent of 74? Now this one's kind of interesting because there is no cotangent button. There is a tangent button. So if you use this up here, that is equal to the tangent of 90 minus 74. So if I wanted a quicker way to get cotangent of that, instead of taking the finding tangent and flipping it, I could just put in my calculator tangent of 16 degrees. Okay, so if you put that in your calculator, I could find it without it. Okay, so kind of interesting maybe. Okay, this next questions are kind of cool too, because here's what they say. If cosine of 58 is equal to this, what is the sine of 32? I don't know if we've taught you enough to understand this or not, but guess what? Cosine of 58 is equal to the sine of 32, right? Because the cosine of 58 would equal the sine of 90 minus 58, which would be 32, which means, sort of by the transitive property, that also equals 0.5299. See how that works? If you look over here, what would this one be? If cosine equals that, find the sine of this. So if you look at that one, what's true, right, is that the cosine of 64, right, depending on how you look at it, right, if you take 90 minus, do we agree that 90 minus 64, right, would give you sine of 26. So if we look at that quick, there's an odd and even part to it. But what you could do with this is say cosine of 64 is equal to the sine of 90 minus 64. So what this turns out to be is the cosine of 64 is equal to sine of 26. Now, if you have a negative 26, what happens here, just so you know, is this minus inside here, because it's an odd function, can be brought out in front. So I don't want to get into that too much, but that's what would happen. So actually this answer would turn out to be negative 0.4384. Okay, so we can talk about that a little bit more in detail. But for now, the cofunction one, this is the one I'd like you to understand. We can talk about when it becomes positive and negative over here, a little more detail. Okay, so those are your basics. What I'd like you to know from this section coming into class is I would like you to refamiliarize yourself with the reciprocal identities. And then the quotient identities, we introduced the Pythagorean theorem identity. I'd like you to be able to use those to simplify some basic functions. Okay, like those. And then down here, I would like you to be familiar here with the co-identities there, where one can be rewritten as another one. Yeah, so we'll talk about